Hi everyone, Thibaut Cantegral here. This is What's New in Octave, your monthly rendezvous live with Octave, the edge-to-cloud data orchestration IoT platform by Sierra Wireless. And today we will focus on the global developer experience with Octave, from getting started to production. So whether you are already familiar with Octave or not yet, you will learn what is a typical developer experience with Octave, what are Octave's main concepts and activities to develop a solution, deploy it, and run it in production. And all that within just 1 hour, questions included. All Octave developer sessions are co-animated by members of Octave development team, and this one is no exception. So to take up this challenge today, it's a real pleasure to welcome our lead for Octave development team, the famous Tom Luxac. Hi, Tom.
Hello, Thibaut. Thanks for the introduction.
So, Tom is a senior director, system architecture, IoT solutions at Sierra Wireless, and his team is responsible for the development of all Octave features. As always, we'll take questions live from attendees. So please use the question box at any time during this session for your questions. We'll take them on the fly when we can, or we'll keep them for the Q&A part at the end. I'm sure you'll have plenty of questions for Tom today. I insist, please ask any question you would have at any time. One more thing, the session is recorded and will be added to our YouTube channel in the coming hours. If you are watching this session on YouTube, check in the description below for the link to register to the live session so that you can interact with the presenters next time. And without further ado, Tom, the mic is yours.
Thank you again, Thibaut. All right. So today I've been asked to give you folks a little bit of an overview of Octave and kind of a 1 hour getting started, how are we doing type walkthrough. And so we'll do a very simple use case. And for those who aren't familiar with working with Octave already, I'll do a high level what is Octave and what it does. So let's jump on in, and I'll reiterate, as Thibaut said, ask questions along the way. I have much more fun in these presentations, and I hope you do as well, when we have a little bit of back and forth, and I can help answer questions that come up. So if you go to sierrawireless.com and you start looking at our marketing materials, you'll see what is Octave. And you'll see this diagram right here. And this diagram gets a few things right, and I think if you're starting from the beginning, what you're going to see right away is that Octave's about connecting your physical thing at the edge, right? So whatever physical real world asset that you would like to monitor that's part of your business or part of your solution, to your cloud system. Now, if you look at what's in the middle of this diagram, you are going to learn a whole lot of features of Octave. You probably won't learn about how it works, but you'll learn a lot about our features. So what do we do? It's about collecting data at the edge. You see over here at the edge on the left side, 5 lines of data. That's meant to show you that we recognize that physical world assets like that compressor sitting there generate hundreds or thousands of events per second, perhaps, right? You probably don't want to feed 1,000 events per second for every compressor that you have into your Microsoft Azure instance you see at the right. So Octave does a job of monitoring and filtering and processing stuff close to the edge so that you send what you need to the cloud and no more, no less, right? So we give you tools to make that kind of top stream happen. At the bottom, we also have this capability of taking cloud initiated events, be they user originated or be they information system originated events, pushing them down to the edge device. And so it's about getting data at the right time to the right asset or cloud service. In short, that's what we help you as solution implementers and solution developers do. We provide a couple things on top of that. You'll see a thing about security there. That's going to be beyond the scope of this getting started call, although I hopefully will have some good questions about it, and I'm happy to answer those. You have Sierra Wireless connectivity in the middle, and that's really key. That's something that we give out of the box that is, we think, a real differentiator for why folks would choose Octave, is the fact that out of the box we have this secure end-to-end global highly resilient cellular connectivity for your edge device to your cloud. And it works through a bunch of different scenarios, and we'll go through those. So that's the high level. This is kind of what this thing does. But given that this is a developer series, right, Thibaut? Yes.
Yes,
So you're probably
exactly.
saying, well, Tom, this is going to help me build anything. So how are we going to build something with Octave? And the answer is I've made a little bit of an overlay here, and you'll see we provide you, the solution implementer, application developer, a set of primitives, basically a set of models and a way to connect them to allow you to describe how you want to flow data between your edge asset and your cloud asset. And it actually works really good with the marking diagram. You see I kind of like blurred it out a little bit in the back. We have some primitives on the edge. This is our new icon set. You will see this new icon set in the UI in this short term. Probably within a few weeks, you'll see this. We have this idea of services that connect to the Sierra Wireless hardware that you're going to be, that connect your physical thing to the Sierra Wireless hardware that you're using. In this case, I'm going to be using some services on a Mango Red board for this demo, but think of services as like applications that allow you to connect to a Modbus protocol, CAN open protocol, GPIO ports, custom serial protocols. We have a special serial protocol called Octave Resource Protocol that allow you to talk, to allow your physical asset, your physical microcontroller to talk to the Octave device. The end goal of all these services is to create a set of resources. And what are resources? Resources are inputs and outputs, sensors and actuators, and they are physical and virtual. So a resource might relate concretely to a GPIO pin that is an output that will be high or low state, or resources could be completely virtual in nature. So they might be the resources might be a configuration for our cloud interface, which is something we're going to go over when we talk about productionalizing your applications. So you have all these services. Some of them come with Octave out of the box. Some of them you connect your physical asset into. How do you describe how you want that data to flow from the resources to the cloud and vice versa? Here we're going to start with a demo that's one directional, but these arrows could flip the other way or be two-headed very easily. And if we have some bonus time, we'll go into some examples of how we send data down to the device, what we would call southbound. So what are observations? So observations are rules that will allow you to observe these sensors and actuators, physical and virtual, on the device and describe how you would like events to flow from those resources to the cloud. In some cases, a simple rule is enough. We'll start our demo with a simple rule, saying we only care about X if it changes by a certain amount. That's fine. Obviously in the real world, we would like to be a little more sophisticated, and as solution developers, as application developers, we can express with simple logic how we would like that information to flow, and that's where edge actions come in. So edge actions allow us to use via simple arity1 JavaScript function, allow us to take an observed value, an observed event from a change from one of these resources, and decide to do some stuff with it, right? So make some higher semantic meaning derived from from an observation, and decide to route our data where we want to route. So that's what an edge action does. Once we get the data to the cloud, it goes into a stream. You'll see that the edge actions and cloud actions icons are pretty similar, and that there's a very good reason for that. Once the data gets into the stream, you may want to stream in the cloud. You may want to make a decision in the cloud context. So you use an action, same program, it's still JavaScript, still an arity1 function that you can use to describe this incoming event or describe the actions to take upon this incoming event. We have something called tasks, which we won't go over today, but I anticipate we'll go over sometimes in a what's new coming up. Those will allow you to essentially periodically execute some logic in the cloud. And then we have connectors, and we won't do too much with connectors this what's up, because I believe what's up number 4, if you look in your YouTube queue, and if you're watching this on YouTube, what's up number 4 will have a couple cloud connector demos to go to. So we'll leave that out of this one for the folks who are regular watchers, right? So those are the primitives. Any questions before I drive on? Thibaut's not telling me that there are. So I will head right in.
I don't see any questions so far.
All right, so we're going to do a really simple use case here. So the really simple use case we're going to do is basically monitoring my Mango to pretend my Mango is in a box, and I want to know if anybody's opened the box or if the box has fallen off of my desk, right? So I want to know if it's bright around where my Mango is, and I want to know if my Mango is tilted, right? So the first thing we have to do for that, though, is we have to set up our Mango to work in a development environment. So we'll talk about first how we would set it up, assuming it comes out of the box, and how the configuration values that are important for you when you're doing basic development. So let's drive into my my Mango Red here. So this is a Mango Red connected to the cloud. I am going to take a look at the resources. So the details show me all the things that are happening, but the resources are really what's important here. So I'm going to turn my device on, and the first thing I'm going to do while I'm developing a solution is I'm going to go over here and look for developer mode. So my developer mode was disabled on this device after an hour of inactivity. So what is developer mode? Developer mode means that when I'm developing with a device, I want the actions and change of state for everything that's happening at the edge to be reflected in the cloud, because I want a rapid cycle, right? A rapid loop of test something out in the UI, see the change on the edge device, create a change on the edge device, see it in the cloud. I want that to happen really fast. So that sends a lot of data. So we'll actually charge you more for a developer mode device depending on what zone you're in. But it's a monthly flat fee, so that you'll have a 1 month it costs you slightly more than a regular device, but it allows you to do this lots more bandwidth and to give you this kind of not real time but closer to real time interaction between the edge and the cloud. So when I start working on a device, if I'm going to be developing a solution, I'm going to turn developer mode. So because it's disabled right now, and I'm going to turn it off and then turn it back on to kind of wake my device up and make sure that I'm in developer mode and I've got synchronization happening. So you see, I've just enabled developer mode and we're good to go. So an important thing to know too when we go to production. Do we want to productionalize developer mode on? No, we don't. But for developing, we absolutely want to start with that. So we'll turn the developer mode on. I have not turned on diagnostic mode here. Diagnostic mode is beyond the scope of this tutorial. Diagnostic mode is something that you can read about on our docs, and it will generate a lot of information, but sometimes it is your only recourse. But I would say do not use this mode. I would suggest that you don't unless you know exactly the consequences, which could be you sending a tremendous amount of data and having your device be spending a lot of time logging information. So right now, developer mode is what you're going to need to get started when you're starting to create your solution. So I'll go through our services here, and you see at the top here, every one of these root mounted things in our resources are organized like a tree, is an application. So the cloud interface is an application, diagnostic is an application, there's a files app, LCD, and a red sensor. So the most important one to kind of differentiate, to let you know about the settings that are important between production mode and development mode, is let's take a look at the cloud interface. Cloud interface is the bit of think of it as the flow controller for your edge device. It determines how often it talks to the cloud. It determines how much data it's going to store and forward. It determines if it's going to heartbeat or not. These are all really important things to be able to look at. So the first thing that's important for a production thing here is config dirty value. So what does config dirty mean? It means that if you have configured a device, and we'll get into that, if you created a blueprint and configured a device and someone has gone and messed with it while it's in kind of a productionalized state, you'll get a true value here. It's true right now because I've been screwing around with the device. But it's an important thing to note as to if you create a blueprint, which is a construct which allows you to describe the configuration of a device in a production environment. If you apply a blueprint and then your co-developer goes in there and messes with a few things, the device will show dirty without you having to check every single value that your other developer might have messed with, right? So long and short of it, it's a quick flag to tell you if a device is in the state that it has been previously configured to be. Connected is not as important as developer mode. So we'll jump right into the most important ones. So you'll see I have close on inactivity true. So if I'm in developing and I walk away from this device for 2 or 3 hours, or I sleep, which occasionally happens, I probably don't need it to be in developer mode, and I don't need to be sending a lot of messages, right? So close on inactivity means that I will close the active connection that we use for developer mode when this device is inactive, i.e. I haven't changed it for an hour. And then the enable flag here is to enable the developer mode. So I can turn on developer mode here via the resource modification configuration thing. Here you see configured value versus reported value. I've configured both of these to be true. They've reported true. Just as easily as changing it up here, I can change it down here. You folks can see my mouse on the screen, right? Can they, Tipo? You can see my mouse?
Yes.
Good. Okay, I want to make sure. I wanted to make sure while we're sharing this way that it's actually possible. And then you can set manually set the inactivity period in hours, probably fair. So that's what we've got for developer mode. And then the other one that's critical for production. So and again, development, you turn this on, and when you go to production, you don't want to turn this on, right? Because you don't want to be charged extra for a device in developer mode every month when you are simply, it's a productionalized device that you're not doing active development or active interaction with. Next thing we've got here is store and forward. This is really the heart of intelligently routing your data to optimize cost and to optimize battery, right? Store and forward is your cache, your local bucket for your local bucket for events on the edge that allows you to group what would be 20 messages into one message, right? So you're only charged for one message on Octave. It allows you to also much more efficiently use the battery for your device if you're on a power constrained device and you do not want to fire up the radio every 10 minutes. You'd rather fire it up every hour unless there is an emergency. Managing store and forward is critical to being able to achieve that efficiency. So what do you have to know about store and forward to be able to achieve that efficiency in a production system? So heartbeat on empty is the first piece, and I think probably the first thing that we should talk about is period. So store and forward period says that I will gather up events written to the store and forward bucket for up to 60 seconds in this case. After 60 seconds, I will send that data to the cloud, right? So controlling how big that bucket is important. To divide up your work into to bucket. Now, notice that we're not telling you every 15 minutes past the hour, every hour past the hour, because we're going to optimize that for you, right? What we're going to say is that, say for example, you send an immediate alert that needs to go to the cloud right away. If you do that, we're going to say, oh, by the way, we may be only 30 seconds into the store and forward timer, but we've got some stuff in there. So with that immediate message, we're going to dump all of the contents of the store and forward buffer, and then we're going to reset the timer to 60 seconds. So you're not saying to the device, I want every 60 seconds on 1 second past the top of the second or the top of the minute to send data. You're saying I want a maximum period of 60 seconds between data dumps or bucket dumps from this particular store and forward buffer. So it's an important thing to manage. So every time you empty the store and forward and send it to the cloud, if there's events in it, it's going to cost you at least one message on our system. So and when that happens, when the store and forward sends all of its data, if you take a look at our details here, you'll see a last seen less than a minute ago. Every time that cloud or that store and forward sends to the cloud, we will update that last seen value. And you say, probably great, Tom. But what happens if I don't have any data in my store and forward buffer, right? And and my 60 seconds is up. Well, if heartbeat on empty is false, we won't send anything. So you won't be charged anything. We will only empty the store and forward buffer every maximum seconds, assuming that there's something in there. If there's nothing, typically we won't do anything unless you turn heartbeat on empty on, right? So what heartbeat on empty allows you to do in a production environment is if you have a requirement for your product that says, I absolutely need to have this device check in with Octave every hour to know that it's there, right? If that was my use case, even if I was not using store and forward at all, I could set heartbeat on empty to true and set this configure this value to 3600, right? So 3600 seconds, set that, and now, and apply it. And now, no matter what, my device will check in with the cloud every hour, and I will have a last updated time on my device. And so if I want to go through my list of all my Octave devices, I can quickly see which ones haven't reported in an hour, so I know that they're not doing the right thing. So that's a pretty important setting to understand how to optimize the solution in a production environment. So these things will affect the store and forward configuration and the developer mode settings are the two most important things to control your cost and to control your efficiency of using Octave. Right now, before I drive on, Thibaut, is there anyone else have any questions on these? Because these are important concepts to kind of operating a scaled Octave solution.
No, I don't see any questions so far. So guys, don't be shy. Please share any question you would have with Tom. Just a quick note, we talked about Mango, and we could have, I mean, Mango is an open source platform we are using as a development kit at Sierra Wireless. There is many different Mangos, but there is as well Sierra Wireless gateways compatible with Octave. So it would be exactly the same for any of these gateways. In the resources you see, or you'll see in a minute, you'll see, obviously these resources are those on the, physically on the Mango itself, but it would be different with an FX30, for instance, but I mean, everything is the same, right? So
yeah, if you're looking at anything that is 77, that has a 7700 chip inside, right? So FX30S, FX3070 with Octave 7702, Mango Red with 7702, Mango Yellow with 7702. Or if you're going OEM and you're building a ton of devices with a 7702 module, this cloud interface will be exactly the same. Exactly the same. It will be configured the same. It will work the same. So that's a really good point you bring up, Thibaut. I might start prototyping my solution on a Mango Red, on a Mango Yellow, like we're doing here today. But if I wanted to go to production with an FX30 or with, with a module itself, the cloud interface rules will not change. It will operate exactly the same way across the entire fleet of 7702 powered devices. As we move on with expanding Octave to other hardware, there might be slight differences, but the concepts we're never going to move away from the concept. Well, I won't say never, but we don't foresee moving away from the concept of heartbeat on empty and period for these forward configurations, no matter what class of device we're on. Same with developer mode. That's always going to exist on every class of device that we have spec'd out currently. So important to note there. So that'll tell us how we control costs and how we control our deployment efficiency. So let's drive on to actually touch back. What are we going to try to do? We've done our setup here. We've talked about some of the resources at the top. Let's do one more set of setup. Let's set up our sensors because we're going to use a light sensor and we're going to use an accelerometer that come out of the Mango Red. We're going to set those up. So first we've set up our communication parameters. Now we're going to set up our sensors. So let's quickly set up our sensors. You'll see that if you get a Mango Red here and it's got Octave on it, you're going to have an app called Red Sensor, which ties all the sensors into the resource tree here. Two ones we're going to use are light and accelerometer. So the accelerometer has an enable disable. The little M here tells you it's mandatory. So I want to enable it. I'm going to set a period for 1 second, meaning that I want to, for my use case, I've got to sample that accelerometer data every second. And it's pretty fast. You probably don't want to send everything to the cloud at 1 second. So we'll talk about how we have a good local data rate that's useful for detection of events that we also then can intelligently process, so we're not killing our cloud. Because you can imagine sending an accelerometer reading every second for a device that's sitting on a table is probably a big waste of power and a big waste of bandwidth. So our edge solution, though, will require us to know at the edge that every second what's our accelerometer reading. And you'll see, because I'm in developer mode, because I've got that configured, my reported value shows up here. So right now, this Mango is flat on my desk. So the Z value, important to know, the Z value is like 10 something. and the X and Y values are around 0. So that's what we've got currently on my desk. Now, the other thing we wanted to do was the light sensor, and I've enabled the light sensor. I've set a period of 1 second for the light sensor, and I've set it to be observed, right? Now we're going to do the observation on this together. But right now I've configured it to say I want light readings every second. All this is done. Now, mind you, this phase, all we've done here now that we've configured these 2 sensors is add those sensor applications. The red sensor application is now writing this data to the resource tree locally. It is not transmitting it to the cloud, other than the fact that we have developer mode on. So we're getting reported values updated every 30 seconds or so for each of these things. So it's important to note that right now I've created a higher data rate, higher sample rate at the edge. It's not getting sent to the cloud, right? We're going to define the rules to send it to the cloud that can leverage the fact that we have a great data rate, a high data rate at the edge, but we don't want to send everything to the cloud. So how do we do that? Again, we'll jump back to, is it bright? Let's ask the question, is it bright, or has the lighting changed? So let's take a look at how we do that. We're going to look at our light sensor, and we are going to create an observation. We have this little eye with a plus sign here to let you know that I want to take a look at that value, and I want to decide what I want to do with it. So if I'm taking a look at it, if I'm sitting on the device and reading that, I might say, well, I do want to send that to the cloud, and I'm going to call this light to cloud. So I'm going to call this rule light to cloud. And you know what? I don't want to send it every second. I could buffer it, but that wouldn't do anything to affect the edge to cloud data rate. Let's think about filtering it. Maybe I want to say that if the value is greater or equal than something, or less than or equal to something. So, here's a useful one. Distance to previous value is greater than. So what this would tell me is that if this value jumps significantly, then I want to report it to the cloud. So let's try the distance to previous value is greater than 10. So I want to send that to the cloud. Maybe I also want to throttle it. So you can imagine a scenario where my light value would go from, what is that, 930 to go 930, 920, 890, 850. Do I want to send every time that changes, every second? Do I need to send that? Maybe I don't. So maybe I say at most I want you to send every 2 seconds. So we'll cut that in half, right? We'll call this one light. We'll just describe it. And this description field has no impact on the behavior. But if you are working if you're working with other developers, it's impolite not to put a description of what this thing does, because they're going to have to guess otherwise. So we're just going to say light changes to cloud. So we'll save this bad boy and put it up there. Now let's take a look at the observation. So we can go to the observation screen to make sure that it's working there. It's called light to cloud. It's reading this resource, it's going to the cloud stream, it's got a throttle of 2 seconds and a filter of delta 10. So let's take a look at my device's streams. Got this light to cloud stream, and it says, oh, my previous value was nothing. So now my light value is 929, and it changed a little bit. I got to change it 10, just naturally, probably from a cloud. But if I move my hand over it and put my hand over the device, we're going to see, oh, wow, it dropped. Right? And so now if I hold my hand here, hopefully it won't change that much. So I'm holding my hand over the device, and the change was reported. Why is this important? In a first-gen IoT solution, and a simple naive IoT solution, this thing would just spam light temperatures, and it would be up to me in the cloud to figure it out. So here, with a few clicks, I put some logic on that, and I'll remove my hand, and you'll see we'll jump up to 918 or something. So now we've got that information set to send me in the cloud anytime there's a significant change in the light, which is nice to know. It's for some solutions, that's all you're ever going to need, right? A simple, I need to know when this value changes, and I'm fine with whatever the last value reported to the cloud is, because if I'm building a solution, a productionized solution, and I want to know what the current light value is, I could say, well, I've got a light reading at 11:32 a.m. I have this device has checked in, last seen, in this case, half a minute ago. So I know that as of half a minute ago, the last time this value changed was this, right? So now this is kind of a slightly more advanced technique, but if you, and I see a lot of folks making this mistake. So to be more efficient, what you can do is say, I want a heartbeat on empty every so many seconds, because it's important to me to know that my device is alive when it's out in the field. I also use some rules to have some deltas in here, like I have here. Anytime this changes over a certain amount, I want to send an event. So in your cloud application, if you say my business requirement is that I know every time the light changes, right? You don't need to send the light every 10 seconds. You don't need to send the light every 20 seconds. You need to say that whatever my requirement for timeliness is, should be the greater possible of the number of heartbeat on empty, the time of heartbeat on empty, and this thing, and the rules inside your observation. So between those, you can be much more efficient. And you can imagine this is a pretty fine-grained control. If I go over to the observation of light to cloud, I then say I want to maybe make this, maybe 10's a little sensitive, maybe 30 is probably better. So if I update this, and by the way, this now sends the new rule down to the device. It'll synchronize once this stops spinning. It'll the device has not only received but confirmed to the cloud that it received the change of observation. So take a look at the stream now. It probably quieted down a bit, right? So if I want to be cost efficient in my solution, I am going to explicitly say what conditions I need to occur to be notified, and set my heartbeat on empty to the right value, and then I can be very cost and battery efficient. It's a little bit of an advanced technique, but it's one that's currently saving people money and saving people battery power to do this properly with these observations. So that's the simple scenario. Again, what we did was we took a look at, is it bright? We took our resource, we created an observation to say, I really only care if it changes every 30 seconds or by 30 count. I want you to alert me in the cloud, maybe every 2 seconds maximum for that. And that's my logic and data flow, because maybe I'm going to send maybe I'm going to use a HTTP connector like we went over in What's New 4 to send a Slack alert, right? Based on this thing. And that's my entire use case. This may be all you need. So hopefully that will be 20 minutes to to value there to be able to do that with your IoT device. So I'll pause again before we jump into something with an edge action. It's a little bit more complicated. Thibaut?
So still no question for you so far. We have 25 minutes left. Maybe we can. So I see. I recognize a lot of folks from previous sessions. So hello guys. Maybe it's still a bit easy for the audience. I don't know. Maybe you can guys watching this live. You can say in the chat, for instance, if you are new to Octave or if you are already using Octave, so that we can maybe adapt what we are showing you so far.
I'm gonna get the JavaScript now, Thibaut. So hopefully we'll get some. Hopefully that will at least confuse some people. That should be our goal at this point.
Okay,
all right.
Good.
So
and
so the next thing we want to know.
And by the way, I like the 10 we have on Z, which is the gravity. So it means you're exactly at almost at sea level if we see 10.
Yeah, I mean, I am. Yeah, I'm pretty close to a river. Like that goes pretty close to the ocean. So yeah, we're not too far. We're a few hundred feet above sea level, right where I am. So yeah, we're at that's that's our acceleration due to gravity. So this is a tilt. Essentially, accelerometer here is like a tilt meter, right? Which axis is gravity pulling down on the most? So when the device is stable. So we're looking at something here where we want to say, well, I want to know if my device has tilted, right? So, or my device, perhaps the box my device is in has been compromised, right? So there's light inside of my device or inside of my box, and I need to take some action. So one way we could do that would be to look at the light sensor, and if it changes drastically, we know that the box has been opened or closed. That we're tracking. And the next thing that we could look at is the box on its side, right? Because maybe it's something that has this way up because it's a fragile thing that we're shipping. So Z being over 10 means that this thing's kind of flat. So what I might want to do is I want to take a look and say, well, if that changes, if my Z value changes, that means that I'm canted somewhere, right? My device is no longer flat. And when that happens, I really want to be able to decide in the cloud. I want to know everything else about my accelerometer, which way it's tilted. I want to be able to also get the light reading, and I want to build a coordinated event in the cloud because I may want to, my application may take those accelerometer values and light readings and make a nice little display for someone to look for a box that's tilted on the side with the outside packaging broken. Maybe that's my use case. So when that happens, I want to correlate. When the Z value changes, I want to correlate all of the X and Y values. I want to correlate the light reading. I want to create a complex event in the edge. I want to basically create an insight using data processing at the edge, and I want to push that up to the cloud. So how do we do that? Let's talk about that. So the first thing we're going to want to do is to create an observation on this value. We know we want all this information in our calculation, so we're going to create an observation. I've already done that ahead of here. So you'll see accelerometer to edge action. So that's typically the way we would name it. It's the accelerometer is going to an edge action. It's going to send everything, and we'll say, is it tilted? Is it tilted? Will be our description. Let's save that. So now that edge action is living at the edge, and the observation that we created will send all of the events, all of the JSON events for accelerometer readings to this edge action. So let's take a look at the edge action we've created and what it does. So in this case, we create actually our XYZ values. So we're getting our XYZ values out of the event. Again, this is a JavaScript arity1 function. It just takes that reading that you saw in the resources display. It gets our values. We're going to say at the same time, I want you to read the timeout value. Why is the timeout value important? This is a slightly advanced bit of JavaScript here. What we're using is a virtual resource. Remember when I said that we had sensors and actuators and physical and virtual? What if you need to create essentially something to store value at the edge? So you have a virtual resource that you're going to write some data to, just like it was a LCD screen, right? So in this case, I'm going to write a number to this thing that says my timeout value, and at the end of my script, and at the beginning of my script, I'm going to read it. So every time the script executes, it checks what the timeout value is for this particular reading, aka I'm using that number to decide whether I should send complex events to the cloud every single time something happens. Just like we used throttle in the observation previously to only send events to the cloud every 2 seconds. Here, we're doing a bit of logic to use a virtual resource to store state external to this function so that we can compare it every time we run it to say, hey, by the way, within 5 seconds, have we done it? Or have we bothered to alert the cloud? So that's what that's for. In this case, we're going to read the timeout value. You'll see right now that it is in the resource tree. Let's leave with unsaved changes. So in the resource tree, you'll see the virtual resource has a timeout value, configured value of 0, but this is run a little bit. So it has a previous value of a Unix timestamp to tell us when the last time I sent an alert on this particular edge action is. So we'll go back to the edge action, take a look at that. And so we're saying if our Z value is less than 9, right? So that means we've tilted a little bit, and should alert is true, which means that we've gotten the timeout value when it was more than 5 seconds ago, right? So we've debounced a little bit that value. Then we're going to read the light sensor. So again, just like we have observations that read resource values, we can read values of resources inside the JavaScript context. We're going to read that value, and we're going to return all that value, one to CL. This is cloud immediate. And there's a bunch of documentation here that can explain what all of these things are. If it's not clear, it's all in line. We're going to say send to the cloud right away an event with all of this X, Y, Z, and light data. So now we've correlated at the time that event was generated where my Z value was low. I'm now also grabbing the light value, I'm packaging that all up together, and I'm going to send that immediately to the cloud. So as we talked about before, what will happen? We will initiate the connection to the cloud. We will see if there's anything in store and forward. If there's anything in store and forward, we'll tack that on and reset the store and forward timer. And then we will send all that information to the cloud. And then we're also going to write to the virtual resource the timeout virtual resource, we're going to write the current time so that the next time we run this in a second, we will check that and see that no matter what happens, we're not going to. So that's a quick, simple way that we can correlate events, across sensors, and to express a little bit more complex logic. And if you take a look at how this will work, it's enabled right now. So I'm going to go to my resources. I will show you, because this is set up to sample pretty quickly. We should be able to see it pretty quickly. I'm going to go to my red sensor, my accelerometer. We're looking at Z is 10, as Thibaut likes, but what if it gets tilty over here? Thibaut, what happens? We're going to see that my my reading should change, and this will only update it about every 30 seconds when I'm in developer mode. But we'll see this change, this number change, and we will see an event appear in our streams over here. We go back to our default. We will see this was, they're coming in every 5 seconds right now. My current light reading, my X value is now -10, my Z value is 1, right? So now you can see that my device is tilted and we're generating new events, and they're coming in pretty handily every 5 seconds. See, 10 seconds after the minute, 5 seconds, 0 seconds. Within about 5 seconds, we can see that we're sending these new events. If I turn that back flat on its side, back to its normal position, you'll see that they stop, right? So what we've done is we've now used an edge action to take a look at data that's routed by an observation, originated by a resource, routed by an observation into the edge action. We've done some correlation in that edge action and decided to conditionally send it to the cloud. And say that's good. Does that everyone follow there? And then we'll move into how do I take this into something that is productionalized.
So yeah, so we have a question. Is there a way to specify a path for an edge action based cloud stream versus only writing to default? I mean, column default stream.
So clearly this person is an Octave user, and yeah, that is on the roadmap right now and is under development. So yes, we recognize that right now the fact that I am writing stuff to the cloud, and then everything that comes out of any edge action I write will always show up in that default stream here. That's now what you could do is you could write a cloud action here to separate this stuff out. I'm sure people have been told that by Octave technical account managers and sales folks and in demos. If I wanted to split this stream of events from all edge actions from this device into separate streams that makes sense in my internal semantics, you use a cloud action here to say if there's a light reading and an X reading, then send it this way. If it doesn't have a light or an X reading, send it the other way, right? We've heard the community tell us that, boy, I sure would like to go into my edge action here. I moved away from it. We've heard the community tell us, I sure would like to be able to say cloud action / and put like, / tilt alerts. A syntax like this. And have a stream created called tilt alerts where all those events would appear. We've heard you. That is under active development. I can't promise right now because I haven't checked in on it in a little bit. I can't promise right now when it's going to be out, but it is. There's no one I think from the product line management or the senior architects on the Octave team who would tell you that this was a bad idea and that we weren't going to do it. So it's coming. I hear you. I feel your pain, and we're going to fix that. For sure.
That's great. Yeah, it's natural. I mean, it's a natural way, yeah. And yeah, so that's legitimate ask. Okay, no, that's great. Just a comment. So that's a great timing to ask Tom about anything about what he's showing now or what are the new features upcoming. Upcoming soon. Or so hopefully we'll have 5 minutes at the end so that you can answer general questions as well.
I have 3 minutes of content, and we're going to have 10 minutes of Q&A.
Okay.
That works for you too. So the last thing I will tell you is that for folks who are new, and I get the sense that some of you aren't. So for folks that are new, that how do I take this? Say I'm happy with my device, and I want to put this in production, right? I want to do a trial. I want to rubber stamp this thing and put 10 of them in the field to make sure it works okay. So the first thing I'm going to do is remember that I made a very clear point in the beginning that cloud interface is how we control our efficiency and cost. So I'm not going to touch anything outside of cloud interface when we go about productionalizing this bad boy. So I'm going to go in here and I'm going to say, let's disable developer mode. Let's set my store and forward to heartbeat on empty, but a very high period. I already did that part, right? So that I know I want this device to check in an hour, full stop. If nothing else is going on, it's fine. It can just say hi. But that's my personal time. If it's more than an hour, I want to know about it. So I'm going to set it to an hour. I'm going to set it to heartbeat on empty true. If that wasn't my requirement, I could also set this to false. I've turned off developer mode. Go ahead.
Yeah, just to interrupt you, we can as well say that the way you're going to be charged is a per message model, right?
Yes.
You are not paying by megabytes or whatever. So you know already by this setting what you will pay, right? So that's very important in Octave, I guess.
Yeah, you can look at this device and know that, okay, I know on average I'm going to send this amount of messages, and a good percentage of them are going to come through store and forward. So in store and forward, we bundle like something like 20 properties together. So if you have 20 single property events, or if you have one 20 property event, it still counts as one, right? So store and forward is how we bundle and make things more efficient. So we'll turn these bits on, this developer mode off. We will configure our store and forward, set up properly, and then we're going to apply that. Now, once we've got that applied, our device is kind of in. You'll see this will change up here once it gets through. Oh, because it's non-developer mode, we're not reporting values all the time. So now we know we're out of developer mode. We do have a little red notification to say that our device has unsaved configuration changes. So, and our diagnostic mode is off. So how do we change that? How do I take this configuration, this edge action, this observation that I know works, and be able to rubber stamp it on 5 devices without having to go through and click all that stuff every single time? Well, you use blueprints for that. So we're going to say this is our existing blueprint. I've played around with it a little bit. It's got one edge action, the accelerometer to EA, the accelerometer to edge action. It's got these resource settings, so you can verify here what all my settings in the resource tree. These are all the things that are set. These are the observations that exist. Send to cloud immediately, send edge action, all that stuff's useful. I want to save a new version. So what I've done now is I've created a new version of that blueprint, version 2, which was created just now. I can then use that blueprint and apply it to all the new devices that I own. So it's a way to go from, I've done a POC, I've gone through and built all my logic. It works fine in developer mode. It's time for me to put 5 or 6 of these in the field to measure the usage, to see if my logic is correct. You're going to go to cloud interface, control how efficiently we are using power and how efficiently we are managing our cost for sending data. And then we're going to save that as a blueprint and apply that to new devices. So as promised in 3 minutes, Thibaut, that's roughly how we take that quick and dirty. Here's some logic at the edge and replicate it out to go from prototyping to building a small POC to then deploying and managing at scale. So with that, I will leave us 9 minutes for questions.
Thanks, Tom. I see Jan raised his hand. Please use the question box for your question. We cannot put you on screen, unfortunately. Thanks. So yeah, so while we are waiting for some questions, I think we will see today a very important things about how you differentiate your development activity versus the production activity, and how you set it up in Octave. I guess that's the first time we showcased this, so it was a very important time. In the next sessions, so this session was a bit particular because it was not like a real what's new in Octave, right? But in the next session, we'll come back to what's new in Octave, and while I'm waiting for further questions from the folks there, can you say anything, Tom, about what we have to expect in the coming month? Let's say what your team is working on.
What we're focusing on.
That's a recurring question.
Some of it we can't talk about. But some things that 100% you're gonna see as Octave users is you're gonna see a lot of work is going into our device twin connector. So if you're using Azure, our currently in preview our device twin connector, we are going to be rolling out support for DPS pretty shortly. Not later this year, but before later this year for sure, right? I've seen the previews and I've seen the code under active development, and it's looking really good. So if you were using Azure Device Twin as a back end for your current solution, or you have a solution that works with Azure Device Twin, and you want to add Octave devices to add another physical footprint for your solution, then it's really good. It's very smooth. The way that Azure Device Twin model integrates with Octave is pretty slick. So I'm really excited to see that. And then a feature that has been asked for by some of our customers for too long. It's taken us too long to get it done, but finally you're going to start seeing files pretty soon. So we know we have a lot of customers who have very specific needs to do firmware updates on the edge. We have customers who are generating large binary blobs of data that is not easily transportable across resources and observations as strings. You can certainly work around it, but we wanted to give them a more elegant way to express their data flow, and those two features are coming out very soon. Again, they're in our staging environment. I played with them, and I think the folks who tune into this call are going to be excited to see them when they come out. I think you're muted, Thibaut, or you've become a mime.
Sorry. Yes, we have questions now. I was saying, are timers okay for production or still in beta?
Timers, I have not used them in anger personally, and I'm not going to contradict any salesperson that told you that, but I will look into it. And Thibaut, take a note as to who asked that question, and we'll look into it. I have not seen many issues with timers come across my desk. I think I've used them and they've worked fine for me. So I'll take a look at our Jira and we'll get back to you.
All right. Okay. Thanks. Another question. Can I manually configure the blueprint? So the last thing you showed us, Tom,
yes.
To update only those things I need updating. So Jan is saying I might have a bug fix in one of my edge actions that I need to send out to all installed units, but I do not want to update individual virtual resources on the different units.
Right. So you're gonna use the Blueprint API to do that. It is not easy to do with the user interface right now, unfortunately. What I would do if I'm coming at it from the UI point of view is to create a device that is not dirty, that has the configuration that I like, make my one modification, and then create a new version of the Blueprint. And you can look at the delta between the two in the UI or via the API. You can look at the delta between the two and make sure it's what you want, and then apply that new blueprint. If you want to do it via the API, if you go to the API docs page, you will see that there is we follow typical REST semantics. You're gonna do a put on a blueprint object. You're probably gonna want to pull the blueprint object, make your modifications, do an update to the blueprint object via the REST API, and then you should be able to do that. Does that answer your question? Is that the scenario you're thinking of? Just one edge action?
I think so. No. Okay, we'll wait for Jan. I'll take another question meanwhile. Is an edge database service on the roadmap?
Well, I mean, I would like to hear what you mean about an edge database service for sure. You've got me in a place where probably I have to do a security clearance for all the things that could come out of my mouth. I think it's a really interesting idea. I would love to hear more about the use case and requirements, because we have some things that we're kind of thinking about. But again, that one I'm not going to answer on the YouTubes. So get with Thibaut and we'll have a conversation offline about that. But it's an interesting idea. There are limitations with what you can do right now with virtual resources, but there are some hacks. If you need database-like functionality, you can put a lot of information in virtual resources. And so, and iterating over virtual resource objects to query through stuff is not as expensive as you would think. So there's maybe a short-term way to solve your problem, but I'm really curious about the full use case for sure.
Sure. So it was a question from John, and we know John quite well in the developer community. He's very active, and he has another question.
That guy always wants stuff.
Is it going to be possible for us to create custom legato services?
Yeah, for sure. There's a guy who's probably asleep right now. I would hope so. Who's already built some custom legato applications that have integrated into the data hub, into the kind of core resource tree in Octave. So it's definitely on the roadmap. It's definitely something that we are building towards right now. There's a lot of infrastructure work that's going in place. One of the things that that you will see us release, hopefully in the next month or two. You're going to see us release a schema that allows us to describe to you exactly all of the valid inputs and outputs for every Octave service, aligned with every version of every module, so that you can ensure that any interface that you're using on an edge device will be essentially guaranteed by Sierra Wireless to be valid, right? So we'll tell you what you can send out to all these things, and it will keep your devices in a good state. So that's an important piece of work, and that is foundational for enabling you as a software developer to develop a legato application that integrates with the Data Hub API, so it shows up in Octave, and then allows you to write a schema in JSON to describe the inputs and outputs, the sensors and actuators, virtual and physical, that live on your edge device, and allows you to send that up to us. And not only are we going to validate your input coming down, we're going to draw a services UI for you. Right? You tell us it's an enumerable value for this particular thing. We're going to give you a drop-down box in our UI. It's going to cost you nothing because our UI will be dynamic and handle it. You're going to be able to maintain that for your legato service. So we're going to essentially let you define a schema for your edge applications that will surface itself natively in our user interface. So we've not forgotten you, legato application developers. That is important to us, and the foundational pieces are being built today. And you'll be able to see the first piece hopefully very soon.
Thanks. I think that was important information. Thank you, Tom. I take another question because the hour is almost past. When collecting data from multiple sensors, what should we do to limit the cost so that it does not get expensive too quickly?
I mean, step one is storm forward, right? Step two is determine what you really need to know and when you need to know about it. So, one of the kind of early use cases, it is such a massive waste that I see people falling into this trap, because the mental model has been that way for a very long time. Is that I've got this industrial piece of equipment with 1,000 measurements on it. We'll say 100 measurements. I've got 100 measurements on this industrial piece of equipment. My my product folks, my users are saying they need an updated value every hour. So beyond just storing forward, we can put logic at the edge to say that of those 100 data points that I am reading every hour, only send the changed ones to the cloud, and then use a cloud action to generate the full report. Because if my destination information system will only accept reports with 100 values, right? I can keep the last known value in the cloud, send the changed values, merge the two, right? And I can use my cloud logic to say, I know what the last scene is, I know what the rules on the observations are. I can validate that this device, the state of this device, I can deduce that the state of this device at this time was this. And send that report in good faith, in full confidence, off to my destination information system. So step one, store forward as much as you can. Step two, only really send what you need to send from a per data point level. And step two is step three is if you need complex reports, only send the change stuff, merge it in the cloud, and then send it to your follow-on information system. Those are the 3 steps I would take from a generic point of view to optimize data point count.
Great, thank you, Tom. Maybe very quickly, any thoughts on large dataset uplinks, like let's say 5 megabytes also per day?
That's going to be if it's fileable, then we'll use files for that for sure. If you run you can run 5 megs a day through a Cat M1. I do it here when I'm testing stuff. So
sure.
through regular Octave. Is that kind of where we're thinking? Are we talking file type objects? Is that where we are?
Maybe, I don't know. So, all right. We'll wait a bit maybe for the answer. Just one quick word. You have on this slide the link to the forum, to Octave forum. Feel free to reach out to us. When I say us, basically the whole development team is on the forum. Tom is on the forum as well. I'm on the forum as well. We'll answer your questions directly on the forum. Any question?
And even if I'm not on the forum, Thibaut will not let a question go unanswered.
Exactly.
He will bother me. Let me know. Tell me answer that question. Yeah.
Trying to keep
We're lucky to have you managing that process, Thibaut.
Thanks, guys. I think we have to call it today. The video will be already more than 1 hour long, and so thank you very much, Tom. Thank you, guys, for your questions, and we'll reach out to few of you guys directly. We noted that we need more things, so I've answered to some of you guys in private in the chat. So we'll get back to you via email, definitely. Thank you, guys. Don't forget to register for the next session. You may be already registered for the next session, but if you are watching this on YouTube, I'll put the description in the I put the link in the description below so that you can watch live the next session and ask your question directly to the presenter. Maybe it won't be Tom next time. Maybe it will be someone else.
Please,
but it will be someone else. But
everyone's tired of hearing me.
As always, from the development team, Octave. All right. Thank you, guys. Thank you, Tom. See you soon. Bye-bye.